Please welcome Daniel closer to the stage.
So, the Azores. I'm going to present you a very interesting opportunity in the Azores that I've come across. But before we go to the Azores, I want to take a step back to really underline the problem. So, I think you've heard now, I spent the last 10 years building hydropower in Africa, building mini-grids. And what I've seen is the problems are fundamentally the same. The only thing that differs is scale. So in Africa, in a small little mini-grid, we might be talking kilowatts. In the Azores, we're talking maybe megawatts. And Texas, he's not here today, they're talking gigawatts. But the problem is fundamentally the same. And this is what I want to go to take you to Africa, and then we'll go back to the Azores. So, you've seen a lot of curves today. Here we have a typical mini-grid, my mini-grid that I built. And at night, everyone's asleep. There's very little need for electricity. So here we see at midnight, it's about 40 kilowatts of power. Then as the night progresses, people get up in the morning, and in the morning at 6 o'clock, the village wakes up. They switch on their kettles, charge their phones, switch on lights, power goes up. So during the day, I have some variability, and the peak is around 6 o'clock in the evening. When everyone comes home, they cook their meal, they switch their lights on, and here we have 120 kilowatts peak demand. Compare that to the 40 kilowatts at night. That's a factor of 3. So that's a huge variability over a 24-hour period. Now the area under that graph represents the energy. So we have on the left, on the x-axis, the y-axis, the power in kilowatts, and on the time of day we have the hours. We multiply the two, we get the kilowatt hour, which is the energy. So the area under that graph is the energy that I can sell to my customer. So that's what creates my revenue. Great. However, to serve that peak demand, I need the capacity to actually generate that peak demand. And I think another thing to highlight here is, here we're talking about just-in-time delivery. We're talking milliseconds. Because we can't store the energy anyway. It has to be generated as it's required, just in time. So as that 120 kilowatt peak comes in, I need that capacity for 24 hours. But most of the day, it's not going to be used. So I have a situation where I can sell 2/3 of my energy, and the other third is essentially, I have the capacity, but I can't actually sell it. I don't have a buyer for it. So if I could monetize that blue area, that would give me 30% more revenue. So I think anyone running a business will understand that's a game changer, because the marginal cost of generating that extra 1/3 is 0. So that's free money. And if I have the Bitcoin network, well, it's a good match. So that's good. Let's take it a step further. Because actually, when I build hydropower, I need to think about what's going to happen in 5, 10, or 20 years. So I have to over-dimension the plant, because I know the village will grow, more appliances will come in, there'll be more demand. Like I said, the problem is the same. It's just a question of scale. So now I have a situation where actually I'm wasting 2/3 of the actual capacity to generate electricity, and I'm monetizing 1/3. Turning that around, it means I can double my revenue if I can monetize that extra 2/3 of capacity. Now that's a game changer. Right, let's go to the Azores. Beautiful island. I'm yet to visit, but I came across a very interesting problem, and I call it the Azores energy conundrum. Because we have a lot of water in the Azores, but more importantly, they have a very big geothermal resource. So we have 3 plates coming together. Let me take a step back first. So we have 9 islands, and they're isolated. They're all mini-grids. We have 9 isolated mini-grids on the Azores. Not one network, it's 9 networks with very little demand. The total demand is about 130 megawatts, split over 9 islands. But more importantly, 2 of those islands use 75% of the power. So we have a very asymmetric situation. Over 50% of that electricity is generated using diesel or heavy oil. So we're burning fossil fuels to generate electricity. That means millions of liters of diesel imports every year, which are burned to generate electricity. And the rest is made up of some geothermal, some hydro, some solar, some wind, to make up the other 55–60% of energy. At night, during off-peak hour, wind is being curtailed. We have a wind developer here somewhere, thank you, which is more wasted energy. At the same time, we're burning diesel. So that's a paradox. There's studies going on to, well, they're investing in battery storage, which is, we've said it before, expensive. And there's also some studies about pumped hydro. Now, pumped hydro is really just a fancy battery. It doesn't actually generate electricity. It just buffers it and stores it. It's just a fancy battery. So where's the conundrum here, you might ask? Well, we have a very active geothermal zone. They're the 3 plates coming together. It's a high temperature resource, which means compared to a low temperature resource, it's actually very cheap to exploit. I don't need to jump through a lot of hoops and hurdles. It's actually a cheap source of electricity. And there's a lot of active exploration, and this started back in the 70s. Now, the important thing to note here, that the expensive part in geothermal is the exploration, because this is a black science. It's not well understood. Unlike if I look at a hydropower site, I can see the mountain, I can see the river. It's very simple engineering. But here I'm talking about under the ground. So today we have about 25% of the energy demand being served by geothermal. Why is it that the Azores are not electrically sufficient, self-sufficient, and we're burning fossil fuels to generate electricity? So this is what I call the conundrum. Why is that? Well, so the problem is, if you look at the graph, there's that yellow area. Geothermal does not have the properties of hydro, of diesel, which means it can only be used for base load. I can only generate electricity at a constant rate. I can't vary the generation to match my load or my demand. Because the green area we saw, that's my variable demand during the day. So geothermal can really serve that bottom base load part, and it's actually less than the base load because I need to keep some diesel running, that when my demand changes, I can supply it just in time. So that really limits my generation capacity for geothermal. And because the demand is low, I can only build a very small power station, and it's about 25% of the total energy need. So we have a problem where we have an unstable grid. We can only maximize so much on geothermal, and at the end of the day, this comes down to a lack of economies of scale. Very small demand, very small power, expensive. Well, you guessed it, the solution. Magic internet money. But let's look at that in detail. What does that mean? If I bring Bitcoin into the equation, I can flip the whole problem around. I don't need to follow a very limited demand like I have in an African village. I can say, well, here's a resource. How much power can I generate with that resource? And it doesn't matter if it's hydropower or geothermal. And for all we know, there's 100 megawatts or 300 megawatts of geothermal power in the Azores. So now we can say, well, let's look at this from an investment point of view. Let's maximize the power Let's build the maximum we can. And then with that power, we will serve the local demand. And all the rest, all the wasted energy that we saw in the graph before, that can go into the global buyer of last resort, the Bitcoin network. There's other benefits to this. Now I don't need diesel generation running to form the grid because I have a lot of inertia with my geothermal, and the load balancing now happens with the Bitcoin network. So I have the Bitcoin network as a load balancer, but also as a buyer of last resort. I have no need for expensive batteries, and they are expensive. Pumped storage is not bad, but it has a lot of lead time to build, and it's also a very CapEx-intensive investment. What does it create? Well, I get energy abundance. I think we've heard this word a couple of times already. Like, I have all the energy I want, which opens up a lot of doors. I get cheaper electricity, and very importantly, I get a very profitable energy project. Thank you very much.
Thank you, Daniel. Thank you.